All right, 5.4, equilateral and isosceles triangles, and 5.5, SSS, triangle congruency theorem, okay? Side, side, side. Learning target. I can use theorems about isosceles and equilateral triangles and the side, side, side theorem to solve problems. So that's refresh our memory on isosceles and equilateral triangles. We know that an isosceles triangle is a triangle that has two congruent sides, right? They are called the legs. So legs are congruent, okay? And we have the base angles, okay, that are congruent. So base angles are congruent as well. Okay, so make sure you know this vocabulary. The vertex angle is the angle that's different. Okay, we have the two base angles, okay, and the legs. Equilateral triangle is a triangle with all equal sides. So three sides are congruent, okay, and the three angles are congruent. So because the three angles are congruent and the sum of the three angles have to be 180, right? If we do 180 divided by 3, right, each angle is going to be 60 degrees, okay? So on an equilateral triangle, each angle is 60 degrees. All right, so the base angles theorem, okay, says that if two sides of a triangle are congruent, then the angles opposite them are congruent. So here, if we use this triangle, we can say that if AB is congruent to AC, okay, right here, AC and AB are congruent, then I know that the angles, the base angles, are going to be congruent, okay? So then angle B is congruent to angle C. Okay. The converse, remember that the converse of a theorem, right, is when you you change the if and the then, right? You switch the order. So here we start with the fact that the angles are congruent. So if angle B is congruent to angle C, okay, then AC is congruent to AB. Okay, so we're going to be using these theorems to solve problems, okay, on the back. Okay, let's take a look at these two theorems involving equilateral triangles. So if the triangle is equilateral, then it is equiangular, okay? So yeah, if the sides are the same length, then the angles are going to be congruent, okay? So if AB is congruent to BC, which is congruent to AC, then angle A is congruent to angle B, that's congruent to angle C. Okay? So the same, so if the converse, right, again, is when we reverse the order. So if angle A is congruent to angle B, congruent to angle C, then these are true. So AB is going to be congruent to BC, is going to be congruent to AC. Okay, so we have the markings here. The sides are congruent and the angles are congruent. So let's look at a couple problems. We start with some simple ones and then we get more complicated. So here, I'm going to solve for x. Well, the first thing I need to identify what type of triangle it is. Since it's an equilateral triangle, I know that the angles are all going to be 60 degrees, right? So in order to find x here, all I have to do is 2x equals 60, right? And then when I solve for x, I get x equals 30. Okay? So I was able to do this because this is an equiangular triangle. All right, now the second one, okay. First, identify the type of triangle. So these two are the same. This is different. So it's an isosceles triangle. So that means that the base angles are the same. That means x equals 50. Okay. And so if this here is 50 degrees as well, then now to find y, all I have to do is y plus 50 has to equal to 180, right? Combine like terms. Minus 100 on both sides. Y equals 80. All right, the next one, this is getting a little bit more complicated. So you have to take a look. Okay, I have a large triangle. I have this triangle right here, right? This, look at the angles. Since the angles are congruent, that means that the triangle is a isosceles. Okay, so this is isosceles. Okay, now let's look at the other one. The other one, I can see that the angles are the same. So if all the angles are the same, this is equilateral. So that means the sides are all the same. Okay, so now we just start. Okay, y equals 4 because I just said that this is equilateral. So y equals 4. Okay, so that means that this side here is 4. This side here is also 4. Okay, so if this is 4 and this is the same, right, because this is isosceles, right, I just have to make x plus 1 equals 4. Okay, minus 1, and we get x equals 3. All right, so why don't you go ahead and try this one, okay? And then we'll take a look at it in class, okay? And let's see this one right here. Okay, this one, let me start. I have two triangles. They're both isosceles, right? So these are the same. So that means these two angles are going to be the same. That's 55 as well. Okay, so because these are 55, I'm able to find angle x. Okay, 55, right? 55 plus 55 gives me 110. So then I do 180 minus 110. That gives me 70. Okay, so that means that x is 70 degrees. So now, because this is 70 and these are vertical angles, this is also 70 degrees. And because this is an isosceles triangle, right? That means these two angles here are the same. So I have y here as well. So here I just do y plus 70 equals 180. 2y plus 70 equals 180. Minus 70 from both sides. I get 2y equals 110. Divide by 2. Y equals 55. Okay, which is, if you noticed, it's the same, right? The two triangles are congruent. Okay, we have the vertical angles here the same. So it ends up that since the sides are the same, that they are both congruent triangles. Okay, I want you to look at this one and try to figure this one out. I want you to remind you that, okay, first of all, full circle is 360 degrees, right? This here is 90. You're looking for x, this angle right here. Okay, so start from that, okay, and then the full circle is 360. So you need to find this angle right here, okay, right, and you need to find this angle right here. Okay, I don't know if it's the same or if they're different, but you need to find those in order for you to find the x, right, because over here is 90 degrees. Okay, all right. This section here is on the side, right? Congruency theorem. We talked about the side angle side on the previous set of notes. The side congruency theorem says that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So here we have AB, okay, is congruent to DE, okay, because of the tick marks. BC is congruent to EF, right, because the tick marks. And then CA is congruent to DF, okay? So then triangle ABC is congruent to triangle DEF. Okay, so let's take a look at how we identify, right, if we're able to use the theorem. Are the following triangles congruent? Right here. So let's see. Well, I have one tick mark here. I have 3 tick marks here, 3 tick marks here, 2 here, and 2 here. So the answer is yes. How do I know? By SSS congruency theorem. Okay, I'm just abbreviating here. Let's look at the second one. Are the triangles congruent? Well, let's see. I have 1 tick mark here, 1 tick mark here. I have 2 tick marks here and 2 here. I'm missing this middle one. Well, the middle one here is shared, right? It's shared, so that means that is the same. So the answer is yes. Again, by SSS congruency theorem. Okay, so every time you have 3 congruent sides, you can use the SSS. So the final thought here is a proof. Okay, I'm trying to show that these 2 triangles are congruent. Okay, first I look at the given information. I already have the tick marks here. These are congruent. ED and GD are congruent. Okay, and I'm trying to prove that the triangles are congruent. So here, this first statement, right, that's the given right there. Okay, you're always going to start a proof with the given statements. Okay, now, all right, I already have 2 pieces of information that I need. These 2 sides are congruent, these 2 sides are congruent. Now I have to match the third side, right, in order for me to use the SSS. So this side, I know they're congruent because it's the same side, right? And we're using the reflexive property here. FD is congruent to FD, okay? Reflexive property of congruency. We're going to look into detail on the properties a little bit later. Okay, so then now I have the 3 sides, so I know that triangle FED is congruent to triangle FGD because of the SSS congruency theorem.